And I will also start recording. And I will also start recording. Okay, it is 6 o'clock, so we can get started. Welcome to the Silicon Valley chapter of IEEE Computer Society. I'm the chapter chair, Vishnu Pendyala. Ours is the largest chapter in the Silicon Valley section of IEEE, with nearly 4,000 subscribers in our mailing list and a strong following of over 12,400 on Twitter alone. We are uniquely positioned by the virtue of our location and available expertise. And today we have our speaker talking on design for sustainability, green hardware and software. So we all know that the world is marching towards digitization in almost every field. Evolution of the Internet of Things has accelerated digitization. While digitization increases efficiency and resilience, at the same time, it is resulting in increased greenhouse gases and therefore more carbon dioxide emissions. Unless the products are designed for sustainability, the carbon emissions will destroy the planet. Not only that, soon we will exhaust our natural resources. To combat this, most technology companies around the world have pledged to meet the net zero challenge. This talk aims at highlighting the concepts of greenhouse gas, GHG as it is called, the need to make products sustainable, design for sustainability for green hardware and software, and typical use cases of green network. Today's speaker is Dr. Ramachandra Gambheer. He is a senior technical operations leader at Cisco Systems, San Jose. He has 31 years of experience in the field of hardware, systems design, Internet of Things, high volume, hardware test automation, and has published several papers in national and international journals. He has designed several FPGA-based embedded systems for various industries, including machine vision. He is a joint recipient of VLSI’99 International Award for FPGA-based design. He is an alumnus and former faculty member of NITK. In the olden days, it was called Karnataka Regional Engineering College at Surathkal, India. His research area is, of course, Internet of Things. He has co-authored a textbook recently. The title of the textbook is Design of Secure IoT Systems, a Practical Approach Across Industries. It is published by McGraw Hill. So let's listen to Dr. Ramachandra Gambheer on design for sustainability. Over to you, Dr. Gambheer.
Yeah, thanks, Dr. Vishnu, for the nice introduction. I appreciate the opportunity given to me by IEEE Computer Society of Silicon Valley. As Vishnu mentioned, I would highlight on these items in the next coming 50 minutes to 1 hour max. So we will spend some time trying to understand what is the sustainability, and then what is the need of the sustainability. Like why should we worry about that as engineers? Then we will look at what is the role of software and hardware engineer in making a product sustainable. And then we will touch upon the concepts of what do we mean by design for sustainability. Then we will look at what is the green hardware and software with use case, of course, in the network field. Looking at the products that is designed which are sustainable and which we call it as a green hardware and green software. And I'll walk you through those. Feel free to interrupt me if you have any questions. We don't need to wait till the end for the questions. And I'll try my level best to answer. And in the event I do not know the answer, I will get back to you offline. So just before we get into the details, I want to set the expectations of this short lecture. So the main purpose of this lecture is to understand sustainability and understand the concept of design for sustainability. And we will look at a few examples of sustainable products in the network field. If you have ever Googled trying to book a ticket, airline ticket, in the recent past, for example, if you try to look what are the flight options that you have between San Francisco and Sydney, which I just took as an example, as you can see on my screen, it not only shows the available flights and prices, it also shows what is the average carbon dioxide emission. It shows for all the possible options what is the CO2 emission. For example, you can see here that it has shown 3 options with lowest as 1,117 kgs of CO2. And it says that for this flight, the typical value is 1,200 and odd, but for this flight, it takes less, which is 10% lower. And Google basically calculates these CO2 emissions per passenger and based on what is the flight carrier, and also as per the norms provided by European Environmental Agency. So using these standards, it publishes and it dynamically shows what is the CO2 emission for a given flight. Now, most of the people choose the flight which emits less carbon dioxide rather than looking at the price or rather than looking at what is the travel time. And wherever there are other possible travel options such as train, the Google also shows that there are other possible travel means such as train, and it shows what is the CO2 emission for that. For example, if you look at the travel between Paris and London, if you take a flight, it would cost or it would consume 54 kg per CO2, whereas if you were to take train, it is only 17 kgs of CO2. So people tend to choose the lesser CO2 emission mode of transport. And this train shows that typically 72% lower compared to going by flight. In fact, nowadays, if you look at Google Maps, for example, if I want to travel from, let's say, San Jose to SFO airport, it shows me what is the CO2 emission on different routes based on the vehicle that I drive. So everywhere it has become so conscious about CO2 emission. If you look at the screen, what I'm showing, some of the consumer products also shows we are going carbon positive by 2025. For example, if you look at the milk packets, it shows that we are going carbon positive. So the whole world is talking about going carbon positive. Why is that? Because there is something called as greenhouse gas. So let us spend some time in understanding what is a greenhouse gas. So in simple terms, greenhouse gas is nothing but the gases in the Earth's atmosphere which will trap the heat. So where is this heat coming from? This heat is coming from none other than from solar. It comes from sunshine, and during the sunshine, all of us know that the Earth's surface gets warmer, and at night it gets cooled down. And when it gets cooled down, the heat is released back into the air. And some of this air is trapped by the greenhouse gases. The majority of greenhouse gases are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. So these particles will trap the heat and they will make the entire atmosphere warmer. Not only that, they will reduce the atmosphere as well. So the greenhouse gases, which is also termed as GHGs, they cause climate change by trapping this heat. So what does this climate change will do? This will result in having the respiratory diseases in addition to having smog and air pollution. So what is this greenhouse gas effect? This greenhouse gas effect is nothing but it is coming from the solar radiation and it gets re-radiated back to the atmosphere. And once it passes through the atmosphere, this is causing the CO2 to be trapped. This is causing the warmness to be trapped, and which will spoil the entire, which will pollute the entire air. Not only that, the ozone also gets expanded because of this. And this carbon dioxide is the primary CHG emission because of the human activities. And because of this CO2, the whole nature is getting affected. And then if you look at the metrics that we have, in 2020, the US electricity generation that is measured by US Energy Information Administration, it shows that 1.71 billion short tons of CO2 has been emitted. One short ton is nothing but 2,000 pounds. This is equivalent to 0.85 pounds of CO2 emission per kilowatt hour. Imagine the amount of CO2 that is being emitted because of the human activities. So when we consume the more energy, obviously there is more carbon dioxide, which results in increased greenhouse gas emission and which destroys the nature. That is the reason why now the whole world is looking at what is CO2 emission for each of the human activities that we are doing. So what do we mean by sustainability? What is that related to this greenhouse gas emission or CO2? So as per University of California, Los Angeles, sustainability is a balance between the environment, equity, and economy. In simplest terms, the sustainability is nothing but how do we make use of the natural resources without completely exhausting that? How do we preserve the natural resources for the future? And all of us know that natural resources are finite, and we do not have infinite resources such as water. We have to always preserve it for future. We have to use it conservatively. So any product that is designed following the conservative principle is said to be a sustainable product. If we do not follow this, then very soon we will exhaust all the natural resources, and we will also, because of the CO2 emission, we will destroy the nature. In other words, the sustainable product must limit the CO2 that it is emitting, or it would make sure that the greenhouse gas emission is minimal. That is the reason why the whole world is now looking at designing a sustainable product. So now we are in the era of digital world. We know the digital transformation. We know what is happening in the world of Internet of Things. Any object can be turned into a data acquisition system and can be connected to a typical wireless sensor network by using appropriate sensor and a sensor network, appropriate sensors. I can have a sensor as an input, actuator as an output, even convert a simple wooden table and chair as a part of network. I can sense what is the usage of table, what is the usage of chair by connecting appropriate sensors to that. Any unconnected device can be connected, and then that can form the part of wireless sensor network, which forms the basis of Internet of Things. If we look at number of devices that are connected today, the study shows that the number of devices connected are almost 4 times the number of human on the earth. According to Professor Francois, if the internet were a country, it would be the 5th largest consumer of electricity in the world. And imagine what would be the CO2 emission just because of this internet. How many devices are connected to the network? What is the data transmission that is going on? And imagine what is the greenhouse gas emission done by these devices. The United States Environmental Protection Agency, called EPA, estimates that 25% of the greenhouse gas emission arise from the production of electricity. Today, we see that everyone will have at least one smartphone, one laptop. And imagine if there are 4 people in a house, there are 8 electronic devices. Then look at our household appliances. We have a dishwasher. We have, look at the number of electrical appliances we have in each household. Look at what would be the CO2 emission done by all this. So if you look at this, nearly 25% of CHG is coming from the production of electricity. And what will happen to the future if we do not design sustainable products? As all of us know, natural resources are always finite. For example, if you look at the material that we use in the LCD, if we start using in the same way that we are using for all of the mobile phones today, within 4 to 5 years, we will exhaust that. We don't find any more LCD products going forward. And all the electronic systems produces greenhouse gases. So each watt by watt that it produces energy, consumes energy, can spoil the planet in finite time. Unless otherwise, we make our product sustainable. Unless otherwise, we design the product as sustainable. And nowadays, you hear a lot of this net zero terminology. We see that many companies have signed up for net zero. What do we mean by this net zero? Net zero means carbon neutral, meaning basically whatever the carbon dioxide that it is, the electricity production is emitting, we will try to neutralize that. And World Economic Forum has taken a lead role in making sure that all the countries come forward, all the technology companies come forward and sign a pledge to make sure that we reach net zero by 2050. Meaning all of the new products that are going to be designed by these technology companies will make sure that they are sustainable, they use the minimum of natural resources, and the longevity would be more, and make sure that the greenhouse gas emission is minimal. So the important thing that the technology companies has to work now, not only design the new products which are sustainable, but what about the products which are being shipped? They also should be sustainable. We have to provide some solution to the existing customer base, existing install base of the product, how to make the existing product sustainable. Otherwise, simply making the new product sustainable is not going to help, because how many customers will buy the new products and install? For example, if you take a service provider, internet service provider, the entire infrastructure is already existing. We cannot ask each of the customer to go ahead and buy a new routers, new switches, make sure that they are sustainable. They have to use the existing infrastructure as well, and then make the existing infrastructure sustainable. So that is one of the biggest challenges which the technology companies are facing today. So most of the technology companies are working towards making the existing product sustainable, in addition to making new designs as sustainable designs. So how do we march towards this? How do we make the whole system sustainable? How do we make sure that the existing products also have the sustainability? So one of the biggest thing to do that is by following a concept known as circular economy. Circular economy is a new concept that most of the companies are following today, where rather than simply make the product, use it and throw it, we try to recycle the product. The circular economy actually differs from the linear economy, where we take the natural resources, make the product, dispose it. Instead of doing that as it is, we make the product, use the product and reuse the product. We will try to reduce the wastage to the minimum possible, and then the unwanted products are repaired, remanufactured, repurposed and reused, refurbished. This whole concept is called as a circular economy. The circular economy is the only solution by which we can make the existing product sustainable. This is the only solution which most of the companies started following to make sure that they provide a sustainable solution for existing install base. So what is a circular economy? The circular economy concept comes from the fact that the product that is already designed, shipped, and then it is installed in the customer base, we will make sure that it is called back and it is repurposed. You minimize the wastage and minimize the pollution right from the beginning of the product design. And not only that, we extend the lifetime of the product and materials, and we regenerate natural systems. In other words, the circular economy attempts to close the loop on wastage by finding a ways to give a new life to the existing resources through durability, renewability, and reuse. Unless otherwise we make every product sustainable, we will not be able to reduce the greenhouse gas emissions. We will not be able to reduce the CO2 emissions. We will not be able to increase the longevity of the product. The circular economy is the only solution today which every technology company started following to make sure that the products are sustainable. Are there any questions?
Not so far. Yeah, you can go ahead.
Thank you. So, having understood what is the sustainability and why we must design the product to be sustainable, let us look at what is the role of software and hardware engineer in making a product sustainable. So, we used to write the millions of lines of code, and then in the olden days, when we write those code, we used to maintain that code for years together. The legacy code was maintained. So that is one of the biggest roadblock for sustainable product. So in order to make the product sustainable, the software engineer must make sure that these are the minimum steps that is required for a software engineer to make the software sustainable or to make the existing product sustainable. Should have a clear software functional specification document, include monitoring dashboards, include debuggability. If the debuggability is not there, then in fact the sustainability is also measured in terms of how much CO2 is required, how many truckloads are required, how many trips are required for a network engineer to maintain the network. For example, if there is a system administrator who is maintaining, let's say, a network, if something goes bad, or if there is a drop of traffic, then he has to go to that place, he has to debug that, he has to make sure that the network is up and running. So the number of trips that he makes is also contributing to the CO2 emission. So in order to reduce that, the debuggability must be introduced into the code right from the design stage. Unless otherwise the code is debuggable, it will not become a sustainable software. And in fact, I read in one of the books, Elon Musk said, never ever try to maintain the old code. Never maintain the code more than 5 years. Always you redesign the code, always you write the fresh code. Because writing the fresh code is much more efficient than trying to maintain the old code, than trying to maintain the legacy code. And then automate the testing. Wherever possible, include the automation packages, you automate the use cases, automate the testing. That way the software becomes more robust and becomes more sustainable. And another important thing the software engineers need to follow is use the simulators rather than using the actual hardware, because using the actual hardware again contributes to CO2 emission, thereby it will increase the greenhouse gas and then it becomes non-sustainable. So use a simulator wherever possible and avoid the use of actual hardware, and use the reliable CI/CD tools so that the development cycle becomes very efficient. And then also by using the UTIT test, that is unit test, integration test, make sure that the total software development cycle becomes very efficient. And another important thing that the software engineer must implement is built-in self-test. The built-in self-test is a piece of code that we can write for every feature testing, for every system testing, and it can also be used to automate the whole system level testing. Similarly, the hardware engineer also have a clear hardware functional specification document.
Rama, before you go there, right, there's a question. So we are fortunate today. We have Tom Coughlin, who is IEEE candidate for IEEE president, with us in the audience. So he has a question: how cost effective is recycling in a circular economy, or when will it be cost effective?
Yeah, sure. Yeah, I just saw the question. Thanks, Vishnu. So thanks for the question. It's excellent question. Yeah, the recycling of the hardware, depending upon what is the value that we get from for that hardware. For example, if I take a network industry, if I have, let us say, a router, if I have a switch, most of the parts in that are obsolete. So in order to actually, if you take the companies like network companies, what we do there is, in order to encourage the sustainability, though there is no actual dollar value for the old hardware, we still take the old hardware and we give the new hardware at a very reasonable price. And the old hardware that we take is basically scrapped. It is not reused. But the new hardware that we are designing now, we are making it modular and we are making it reusable. In fact, I have one of the slide on that to show in the design for sustainability. I will cover at the time. But just to answer your question, there is no dollar value that the companies get when we buy back the old hardware, but we basically scrap it. We scrap it. We don't reuse that hardware at all.
Thanks, Rama. And Vishnu, I'm sorry, but since you mentioned I'm a candidate for IEEE president, I'm supposed to mention that there's 3 other candidates also for IEEE president. There's information on all of us available on the IEEE website. So sorry to interrupt, but I needed to say that because you mentioned that. Thank you.
Oh, thanks for the clarification.
You're welcome.
Yeah.
So I was talking about having a clear hardware functional specification document, and then include visible and audible alarms. This is one of the main thing required in sustainability for a hardware engineer. For example, if you take some of the, let us say, a simple laptop charger, some laptop chargers will have a small LED showing that, okay, you are getting the required 12 volts there. Some laptop chargers will not have a LED there. If we look at the difference between that, let's say the laptop is not getting charged, then look at the resources that you spend in order to find out whether the charger is working or laptop is working. If at all it had a simple indicator such as LED showing that, okay, 12 volts is available, look at what is the amount of time that you save there, what is the amount of resources that you save there. This is the simplest example for design for testability. So always having a visual and audible alarms saves a lot of time and then energy efficiency, which make the product sustainable. And then another important concept is include the testability, which we call it as a design for testability in hardware. Design for testability is nothing but any hardware product that you design should be testable without going into the details. In the sense, I should have the necessary test points, I should have necessary test ports where I should be able to tap and look at the waveforms, I should be able to check the voltages, I should be able to check the functionality of the entire hardware. So this, in order to check the functionality of the entire hardware, the concept has to be built right in the design stage. That is what is called as design for testability. It is very similar to including debuggability in the software. The software debuggability, hardware testability are similar. And then another important point to consider for hardware is the shelf life of a product. See, every hardware component has something known as a shelf life. For example, if I simply buy a simple capacitor, put it in the shelf, after 6 months, the capacitor cannot be used because it will discharge completely and then it cannot be charged further. So there is something called as a shelf life. Take the normal battery cell. If you don't charge it, if you leave it like that, it will discharge completely and it cannot be charged again. So that is called as a shelf life. So we have to consider shelf life of the hardware component, make sure that we use that component within the shelf life. And then we have to start using the test fixtures wherever possible and avoid resoldering of the components. That way, again, we will reduce the greenhouse gas emissions. And wherever possible, we should use debugging tools such as JTAG tools so that you can emulate the hardware, go into the details of the processor, go into the single step, check what is happening, check what is the contents of each register, do a single step, and it becomes much more efficient to debug the hardware. And then another important thing is today, most of the technology companies, the problem they face is RME. RMA is, if you go to the customer support engineer, the easiest that he can make is RMA the hardware. If, for example, if you call the service provider and say my internet is not working, then they will say, okay, you return the router, go to the UPS, and then you dump your old one, we will send you the new one. That is RME, Return Merchandise Authorization. RMA costs a lot to the companies, not only for number of truckloads, but also to repair that hardware. So always now the companies are moving towards an intelligent RMA return, meaning if a customer complains that my hardware is not working, they would not blindly replace the hardware. They run certain test patterns to make sure that there is a real hardware problem or not. Only if there is a real hardware problem, then they do the RMA, they provide the new hardware. Otherwise, they will say there is no problem with the hardware. There is something called as a signature analysis that is being implemented by most of the hardware companies today. Also, we should try to use the local repair than sending it to the other countries. Again, as you saw at the beginning of my lecture, for each of the flight, there is a CO2 emission associated. So in order to reduce that, we should reduce the RMA of the product as well. And another most important thing is something similar to software, what we discussed, built-in self-test. Each hardware can have a built-in self-test as well. We can have a small FPGA or CPLD, field programmable device, that is loaded with the test vectors, which will test the entire hardware, make sure that the hardware is functional. It is something like when a motherboard boots up, it will do power on self-test called POST. Something similar to POST, all of the hardware systems can be tested by using a built-in self-test. That way, the designed product becomes more sustainable, and then we will reduce the RMAs in the hardware. So these are the steps that software engineer and hardware engineer need to follow in order to make the product sustainable.
So Rama, are there any metrics which show how effective these guidelines are?
Yes, in terms of sustainability metrics, today we have what is known as, we measure the CO2 for each of the product. In fact, as you know, in Cisco, we call it as PID, product identification. Yeah. So for each of the product, we measure what is the CO2 emission, and the CO2 emission tells us that by following the guidelines, what is the CO2 emission? Without following the guidelines, what is the CO2 emission? And this CO2 emission is also now the new metrics are coming up. Even IEEE is working on that. The new metric shows that what is the kilowatt per byte of the data transmitted. So that will tell us by following these new guidelines, what is the CO2 emission, what is the greenhouse gas emission that you did, and without following, what is that you did. Those metrics are available, and then companies started documenting that.
Okay, and do they typically advertise these numbers along with the product? Or?
They started advertising this. Unfortunately, it is still in the works, in the sense there is no common agreement across the companies. Each one have their own ways of measuring this. But IEEE is working to have a standard for this, so that every single company, for whatever the hardware, software they do, the measured metrics are similar. Once the measured metrics are similar, I think then the companies will start publishing this data.
Okay. Thank you.
Right now, the measurement is not uniform. That's what I mean. The way how I measure is totally different from how other company measures. It's not standardized.
Okay.
Even to give you one more example, Vishnu, if I say, for example, I have a line card. If I say, okay, my line card is consuming 5 kilowatts, I will not tell whether it is with optics, without optics, is it with fan, without fan. Somebody might be measuring with fan, somebody might be measuring without fan and saying that it's only 1 kilowatt.
Okay, so IEEE is working on standardizing.
Exactly.
Okay.
Because as we see, right, in especially network products, if you see, the line card alone does not consume much power, but the much power is consumed by optics and fan.
Oh, yeah.
So what should the product design consider? Any product that we design today should consider these three things. First one should be design for testability, design for manufacturability, design for sustainability. What do we mean by design for testability? For example, if I design a best product in the world, but it is not testable in when I scale it, meaning, let's say I have designed a wonderful smartphone, and once I design the wonderful smartphone, and once I productize that, maybe I wanted to produce 1,000 smartphones per day in any of the electronic manufacturing facility. Once I take it to electronic manufacturing facility, all of the 1,000 phones should be testable. How do I test that? It is not possible to power up each one. It is not possible to check every single circuit component in that. That should be automated. For example, if I design an electronic calculator, it should be repeatable and reproducible. If I say 2 plus 2 equal to 4, 2 plus 2 should be 4 all the time, every time. I cannot say that 2 plus 2 will be 4 only in the morning. It has to work all the time, same results, which we call it as repeatability and reproducibility. So any product that I design should be repeatable, reproducible, testable. And this has to be done right at the design stage. For example, again, I was quoting the LED one for a laptop charger. Similar to that, if I design a hardware product, I should have one LED to indicate that, okay, when power is there, when 5 volts is turned on, maybe there is a green LED. When 12 volts turned on, there is maybe red LED. And when ping test is passed, maybe there is another green LED. So these visual indicators tells me so many things about the functionality of that. Similarly, I can write a simple Tcl script or a Python script to test the pattern in a given hardware. Unless this is possible, unless otherwise, I provide the test points on the printed circuit board. So these test points have to be provided at appropriate place, so that in a production line, all of the products, 1,000 products that I design per day, 1,000 pieces that I manufacture per day are testable. That concept is called as design for testability. So unless otherwise DFT is implemented, the product is not scalable. In very similar fashion, we have a concept called as design for manufacturability. What is it? What do you mean by design for manufacturability? For example, let's say I wanted to stitch a very nice blazer for me. I cannot go to any tailor shop and ask him to stitch. I should see whether the tailor is capable of stitching the blazer or not. That is what is called as design for manufacturability. If I design a product, I should first consider which manufacturing facility I am producing that, which manufacturing facility I am scaling that, which manufacturing facility I am manufacturing in high volume, look at that manufacturing facility details. For example, let's say I'm going to one contract manufacturer in, let's say, China. I should look at the contract manufacturer's abilities. What is how many number of PCBs they can do it per day? What type of printed circuit board they can do it? Is it like double-sided printed circuit board? Is it blind and buried printed circuit board? Or what is the number of layers that I can have in a printed circuit board? If I go for 30 layers in a printed circuit board, but if the contract manufacturer is able to design only 20, then I will not be able to go to that contract manufacturer. I have to change it. But if I change the contract manufacturer, maybe the cost will change. So while designing the product, we should keep in mind which contract manufacturer is going to productize, which contract manufacturer is going to produce that in high volume. Based on their abilities, the product has to be designed. That is what is called as design for manufacturability. Now, the new concept is added to this, which we just went through a little more details, design for sustainability. So have a design for testability, design for manufacturability, design for sustainability. Design for sustainability is to make sure that the product is sustainable, the product emits minimum CO2 or greenhouse gas, and product is durable, and the longevity is more, and then we will have minimum maintenance in that and maximum automation in that. That is what is called design for sustainability. We will go into little more details of design for sustainability to understand what concepts are included. So the biggest consideration today for any electrical product design is the power consumption. In fact, I was just answering one question to Vishnu and telling if you take a line card in a network line card for a router or for a switch, the line card alone consumes only 1 kilowatt. But the fan, which is used to cool down the ambient heat emitted by the line card, consumes more power than the line card itself. Or if I have a high-speed data transfer, I would be using a small form factor pluggable optics, which is called SFP. This optics would consume more than double that of what line card power consumes. So if I look at the total system power consumption for a line card of 1 kilowatt, the total power consumption will be 5 kilowatt or 6 kilowatt. That is because of these external fans, external optics. So we have just learned more power consumption means more CO2 emission, and that will also increase the greenhouse gas emission. If greenhouse gas emission is increased, then we don't call that product a sustainable product. We should always reduce the power consumption so that CO2 is less and then GHG is less. Only having the lesser GHG emission makes the product more sustainable. As I was showing you in my first or second slide, how when you try to search for the flights between the two places, what is a CO2 emission? Now every single hardware product, if you look at the product collaterals, they mention what is the CO2 emission, what is the GHG emission, because no more it is an option. It is a mandate now done by many countries in the world to make sure that you can sell your product in the market unless otherwise your product is sustainable. So the new forms or new norms are coming into picture very soon. Even IEEE is working for that to set the standards. For example, if you look at any of the wireless products, FCC has set certain rules. If the emission is beyond the predefined value, then you cannot sell that product. In a very similar fashion, we are going to get the rules which will tell if the GHG emission is more than a specified value, you can no more sell that product in the market. That's coming very soon. Most of the countries are working for that. IEEE is also working to set the standards. And then once that standard is set, that is what we are all marching towards net zero. And from 2025, most of the countries are going for implementing new network standards, which will tell, unless otherwise your product is sustainable, the CO2 emission is below certain defined value, you will not be able to sell in that particular market. So both software and hardware engineer need to contribute to achieve this. In just the previous slide, we had seen what are the points that software engineer has to keep in mind, what are the actions that hardware engineer has to do. Unless otherwise collectively both of them do, the product will not become sustainable. The automation layer plays a very important role in software to make the whole product sustainable. And most of the times, the products that we design are business class products. It's a overkill. For example, take our own smartphone. It has 150 features. Look at the number of features that it has and number of features that we use. We hardly use maybe 15 to 20% of the features. Remaining features we will not use. Maybe 20% of the people use 40% of the features, and remaining 20% use another 20% of the features, and so on. But the total population using all 100% feature is almost nil. So we should always try to design the product without any overkill. For example, if you take, let's say, if the power requirement is only 1 kilowatt, maybe we will try to design the product which consumes 2 kilowatt. And we will put number of features which not required actually. So we should try to change our design style. Design more products, but with less number of features, so that people will choose what product they need with the features that they want. And use less number of cores in a processor. If you look at the MIPS, million instructions per second, since we are putting hundreds of features in a given product, I wanted to go for a 4-core processor, 6-core processor, 10-core processor. More and more cores that you have in a processor, it dissipates more heat. Once it dissipates more heat, look at our motherboard of the PC motherboard. The processor is small, but look at the fan. Look at the energy it takes. Look at the noise it creates. So this is making the product not sustainable, unsustainable. So in order to make it sustainable, we have to really choose the required number of cores just suitable for that processor. Don't overkill. Don't choose the processor unnecessarily, which is more powerful. Also, choose the smaller capacity SSD, silicon storage device. Now what we are doing, we are writing a huge code. We are choosing the huge SSDs, which is again not only increasing the cost, but I need more battery. The moment it is more battery, I need to charge it, then back to CO2 emission, back to greenhouse gas emission. So choose the SSD as minimum as possible. Make in-system software upgrade faster and easier. And use scaling only if necessary. In fact, most of the products today, we use what is known as a graceful reduction of scale. If I have, for example, let's say 10,000 ports, if not all the 10,000 ports are used, maybe I should turn off some ports in the night time so that at least the power dissipation in the night comes down. Maybe I should try to turn off the radios in the night when there is not much of a traffic. Also, another important thing that the software company need to do is reduce the SMOS, software maintenance upgrades, because each software patch will take a lot of development cycle. We have to do unit test, integration test, we have to do the all kind of tests, and then that is again consuming energy, that is again releasing greenhouse gases. Again, it is making unsustainable product. So we have to reduce the SMOS, have one single umbrella SMO so that the software becomes sustainable. And another important thing, so this was a question earlier brought up, the common reusable hardware. If we have a common reusable hardware, then it makes sense to recycle that. Once I get back the hardware from the customer as a part of circular economy, circular operations, I can reuse those hardware products to other hardware modules in other products. For example, right now, the field replaceable units, FRU, what we call, are only fans and power supplies. But going forward, we should make hardware design as all the modules, so that once I get back the old hardware, the modules can be dismantled and can be used for other products. And then we should also use the common test beds, use the common automation packages, so that more products are testable with less number of test beds. And then again, this point we discussed, use simulators wherever possible in terms of the actual hardware protos, so that you reduce the overall hardware production. And then use automation and cloudification wherever possible. Consider cloud computation in place of edge computation, so that it can be distributed to more consumer products than computing at each of the consumer products. That way, we are overall contributing to less greenhouse gas emission. And turn off the high availability when network traffic is considerably low. Also turn off the radios in the midnight, so that we are again reducing the greenhouse gas emission. And we should also consider turning off the ports when traffic is low, and reuse the protos, use software modular design, so that we don't need to rewrite the software for each of the new products. And another important architectural change that most of the companies doing today is hardwiring the commonest software routines. In fact, for example, if any product that you develop, maybe 10 or 20 software features are common. What we can do is, instead of writing a software, running it through the processor, we could hardwire it in application specific standard product, which is CPLD or FPGA. That way, we don't need to write the software, we don't need to download the software, we don't need to run the processor always. Once it is hardwired, it is always connected. We don't need to download the code and run it. So most of the companies are doing this today in order to make the product sustainable. And then another important thing is use the smart fan algorithms. Rather than all the fans turned on all the time, we turn on the fan only when more cores are turned on, only when the power dissipation or the heat dissipation exceeds certain value. So there will be sensors which will sense the temperature. The temperature goes above certain predefined value, then only the fan turns on. Otherwise, the fan will be off. So most of the network products today, they use smart fan algorithms, so that the CO2 emission is minimized. And then we should also consider going for power efficient optics, so that optics alone does not consume more power than the line card and the fans. So these three are the key pillars of sustainability: architectural optimization, operational excellence, and circular economy. So I have actually discussed these points in detail. I've just summarized here. Are there any questions?
So I don't see any on the YouTube channel yet. But I have a few questions.
Go ahead, Vishnu.
How ready are the EDA companies, or how cooperating are the EDA companies, electronic design automation software? How helpful is it in the sustainability aspects?
Yeah, EDA companies, it's a very good question, Vishnu. EDA companies have changed their architecture now, and they are also working towards providing a sustainable product. For example, since we're talking about EDA company, for example, if you take let us say, a routing company, like I am talking about PCB routing. If you take a routing company, if you have a net list, it will try to optimize such a way that the power dissipation is less. It will try to choose the minimum number of tracks, minimum number of track length, so that the overall power dissipation is reduced. So most of the EDA companies are implementing sustainable designs. Even if you look at the, for example, synthesizing the hardware, these EDA companies are implementing the sustainability algorithms. They are ready.
Okay. That is good to hear. And there are a few mentions in your slides which are not very intuitive. Like you said, moving the computation to cloud rather than at the edge is going to help with sustainability. But then wouldn't we contributing to the network bandwidth consumption?
No, okay, that's a good question. So here, when we move the computation to cloud, if there are common things to be done, we compute only once and store the result, and then we don't need to recompute that again and again. For example, if you take certain apps where you are trying to, if you look at the traffic of the apps, let's say there is a particular app downloaded into 10 smartphones, the amount of reusing the app for a known application is more than using it for unknown applications. So these known applications are already computed and stored in the cloud. So only the result is what is device, rather than computing in each of the edge device again and again. For example, rather than 10 edge devices doing the computation, there is only one device which does the computation and store the result in the cloud.
I'm going to dispute a lot of that. Like edge is where you generate your renewable energy. So that's where you're going to want to do your compute. And the EDA companies have done very little to save power. For the background noise, my wife's burning something.
Okay, sorry, there's some noise. Vishnu, could you hear that?
Yeah, so I think Kevin has a comment. He says that, or rather, he feels that edge computing is more sustainable than cloud computing because edge is more renewable.
I mean, I'm working on the Open Compute project, and one of the guys there is trying to do sustainable computing with geothermal. So you move the compute to where the energy is cheapest.
Yeah, that depends on the application. It depends on the application. So,
well, which applications does that not work for?
Yeah, no, what I mentioned was, if there are repetition, if the same kind of things are done in the edge, rather than doing the same thing again and again, for repetitive,
you have the cost of moving stuff. If you're doing it, if it's easier, it's cheaper to move it to where you need it and cache it there.
Yeah, that depends on
your
the
argument doesn't hold.
Depends on the application. Depends on the depends on what amount of data that we are moving to the cloud. If the amount of data we are moving to the cloud is huge, then it makes sense to have the edge computing. But most of the companies today, for the repetitive nature, for example, if you take let's say the windmill computations, what they do, they put it in a cloud and then they only transfer the instructions to the windmills. I'm talking about such things, not the handheld devices.
Not following you with the windmill thing. But I mean, a typical example of where you could do your computes at the edge more easily is when you're curtailing power from solar and wind. Hawaii curtailed like 28 gigawatt hours or something a year or two ago. There were 3.82 terawatt hours curtailed in wind power in Scotland. So you want to move the compute out there.
No, this is the okay. Maybe another example that we could take is where this concept of cloud computing works for sustainable operations, where the repetitive is the nature of the computation. If I have, let us say, 10 devices or 10 locations, the same kind of computation.
I think it works if you can put a server farm somewhere where your energy is renewable and cheap.
Exactly.
I don't think it works for the other scenario you're talking about.
No, it depends upon
Unless
the
you can't
type of
move the compute for
computation.
some reason.
No, it depends on the type of computation. If the computations are repetitive in nature, only those cases having the computation in the cloud saves the energy. If it is not repetitive, then it doesn't make sense.
Well, I think it's a question of the machine size. If you can't move the machine, or if you can't replicate the machine where your work needs to be done, then you need to move the work to the machine. That's a particular case.
Yeah, it is case by case basis. We have to look at the case by case basis and look at what is more optimal, what is more sustainable. Based on that, the decision need to be taken. It is not like generalized comment.
Okay, so it's not like a silver bullet. I mean, we need to consider, and that is one of the considerations to keep in mind. That's what Rama seems to have indicated.
Yeah. So my point there is where there are repetitions, that makes sense to have in cloud, but not always.
I think it's something like quantum computing. I mean, it's unlikely you're going to have a lot of quantum computers out at the edge. So you have to take the work to your quantum computer.
Right. Yeah. Any other questions, Vishnu?
Yeah. So one other question that lingers is there is increasing demand for computational power, right? You take blockchain, for instance, this proof of work thing, and you take deep learning. There's increasing demand for GPU resources.
Yes.
How do we address sustainability in those kind of environments?
Yeah, there the first thing that we need to have is, again, in any of the products, once we talk about sustainability, the first thing is reduce the greenhouse gas emission. That is the number one metrics that every organization is measuring today. So in case of this, the first thing that we need to do is, again, compute what is the CO2 emission, and based on the CO2 emission, we have to find what are the means to make the whole product sustainable.
Okay.
Did I answer you, Vishnu?
Yeah, sort of. But it doesn't seem like there's much of work going on in the blockchain space or in the deep learning space for sustainability.
Not really, because the major thing first, the whole world, if you look at the sustainability resources, right, the first thing that people are working is towards making the hardware product sustainable first. That's the top priority right now. Once the hardware products are sustainable, I think then the research will start in other allied computational fields.
Okay. Yeah. That's what it seems like. Yeah. So
but every sector, lot of research work going on in sustainability. In fact, most of the universities today, they are offering sustainability courses, including the grad programs, even certificate programs. A lot of research going on in power sector, in natural energy sector, in hydraulic power sector, and also in the wind tunnel, in energy sector. A lot of sustainability research going on.
yeah, I just searched on Google Scholar, deep learning sustainability, and I see 86,300 results.
Yes.
So yeah, I think it's a hot topic. So I guess we don't have any more questions from our audience. Let me check YouTube channel. Yeah, there aren't any questions. So it was really enlightening, insightful talk, Rama. Thanks for taking time to talk to all of us. And so here's a small token of appreciation that I'd like to present to you. Of course, if it was in person, I could have handed it over to you. a plaque, but since it's online, I can show it on the screen. So this is a token of appreciation for you.
Thanks, Vishnu. Appreciate.
Yeah. And so I just want to conclude with the future plans for the chapter. So today we had this talk by Dr. Gambheer on design for sustainability, green hardware and software. The May event is a conference. It's New Frontiers in Computing Conference. So that's like a half-a-day conference. It is still in the plans. And the June event is an open house. There's a technical talk, machine learning, the motor of modernization. That will be presented by me. And I'll also give the state of the chapter. It is planned to be in person. It will be in Semi. The office is in Milpitas. So hopefully most of you will be able to participate. And then we're always looking for volunteers. We started a magazine called Feed Forward. So we need editorial support, and we need folks to handle our social media and publicity. We also have a plan to organize a second conference called ICATS, International Conference on Applied Data Science. So which will be in July, actually. So any help with the conference organization is welcome. The idea is to tap the potential of hobbyists, or rather the serious researchers are anyway oriented towards the reputed journals and things like that. But there's a whole community of writers and researchers who do not meet the rigorous standards of research, but they still do commendable job with either their writing or their research. So the Feed Forward magazine is for the writers, such writers, hobbyists, who have interests in artificial intelligence and various other fields of cutting edge areas of computer science and computer engineering, and including hardware and software. So that is the Feed Forward magazine. And the research interest, folks with research interests but who do not meet the rigorous standards of research publications can consider this ICATS conference to present their work. So it is expected to be online completely, and one-day conference. That is the ICATS conference in July. And then we need volunteers for member recruitment and any other way. We always welcome volunteers. So please visit our website to submit your interest, or you can email me whenever you can. So with that, let's thank the speaker and end the session here. Thank you all. Thanks for attending.
Thanks, Vishnu.
Yeah, thanks.